All right, we're in the helicopter flying handbook. This will be chapter 3, anti-torque pedals. This is page 4 of 6, anti-torque pedals, or on actually the book 3-4. So this will be 4 of 6 for me, for my videos. The anti-torque pedal is located on the cabin floor. By the pilot's feet control the pitch and therefore the thrust of the tail rotor blades of the or other anti-torque systems. See Chapter 5. Helicopter components, sections, and systems for discussions on these other systems. Newton's third law was discussed in Chapter 2, General Aerodynamics, stating that for every action there is an equal and opposite reaction. This law applies to the helicopter fuselage and its rotation in the opposite direction of the main rotor blades unless counteracted and controlled. To make flight possible and to compensate for this torque, most helicopter designs incorporate an anti-torque rotor or tail rotor. The anti-torque pedals allow the pilot to control the pitch angle of the tail rotor blades, which in forward flight puts the helicopter in a longitudinal trim, and while at a hover enables the pilot to turn the helicopter 360 degrees. The anti-torque pedals are connected to the pitch change mechanism on the tail rotor gearbox and allow the pitch angle on the tail rotor's blades to be increased or decreased. Anti-torque pedals compensate for changes in torque and control heading in a hover. Heading control. The tail rotor is used to control the heading of the helicopter while hovering or when making hovering turns, as well as counteracting the torque in the main rotor. Hovering turns are commonly referred to as pedal turns. At speeds above transitional lift, the pedals are used to compensate for torque to put the helicopter in longitudinal trim so that coordinated flight can be maintained. The cyclic control is used to change heading by making a turn to the desired direction. The thrust of the tail rotor depends on the pitch angle of the tail rotor blades. This pitch angle can be positive, negative, or zero. A positive pitch angle tends to move the tail to the right. A negative pitch angle moves the tail to the left, which no thrust is produced with a zero pitch angle. The maximum positive pitch angle of the tail rotor is generally greater than the maximum negative pitch angle available. This is because the primary purpose of the tail rotor is to counteract the torque of the main rotor. The capability of the tail rotor to produce thrust to the left negative pitch angle is necessary because during auto rotation the drag of the transmission tends to yaw the nose to the left or in the same direction the main rotor is turning. From the neutral position, applying right pedal causes the nose of the helicopter to yaw right and the tail to swing to the left. Pressing the left pedal has the opposite effect. The nose of the helicopter yaws to the left and the tail swings to the right. With the anti-torque pedals in the neutral position, the tail rotor has a medium positive pitch angle. In medium positive pitch, the tail rotor thrust approximately equals the torque of the main rotor cruise flight, so the helicopter maintains a constant heading and level flight. A vertical fin or stabilizer is used in many single rotor helicopters to help aid in heading control. The fin is designed to optimize directional stability in flight with a zero tail rotor thrust setting. The size of the fin is crucial to this design. If the surface is too large, the tail rotor thrust may be blocked. Heading control would be more difficult at slower airspeeds and at a hover, and the vertical fin would then weather vane. Helicopters that are designed with tandem rotors do not have an anti-torque rotor. The helicopter is designed with both rotor systems rotating in opposite directions to counteract the torque rather than a tail rotor. Directional anti-torque pedals are used for directional control of the aircraft while in flight, as well as while taxiing with the forward gear off the ground. In intermeshing rotor systems, which are a set of two rotors turning in opposite directions with each rotor mast mounted on the helicopter with a slight angle to the other so that the blades intermesh without colliding, and a coaxial rotor system, which are a pair of rotors mounted one above the other on the same shaft and turning in opposite directions. The heading pedal controls the heading of the helicopter while a hover by balancing torque between the rotors, allowing for the torque to turn the helicopter. Chapter summary. This chapter introduces the pilot to major flight controls and how they work in relation to each other. The chapter also correlates the use of flight controls in aerodynamics and how they work together to make flight possible. So there's some pictures. Pictures. Brief recap. Let's see. Okay. Cool. And that was the end of chapter 3, the major flight controls in a helicopter. See ya.